to the cloud. All right, we are recording to the cloud. Let us prepare for some coordinate fun. So, hello and welcome to a Math Miker video. These videos are intended for my students who may have missed a class or who may want to go back and review a concept that are preparing for the HISET or the GED, high school equivalency exam. So the concept that we're going to go over in this video is the coordinate grid. And there's some interesting things that are potentially going to be on the HISET or the GED that involve the coordinate grid. And one thing that can happen is a lot of teachers, myself included, will assume that people kind of remember this because this is something that, you know, you get to do everywhere from elementary school up through high school. So most people have had a shot at this, but that doesn't mean, like we know, that doesn't mean you know it. And that doesn't mean you remember it. So here's the things that we're going to go through on the coordinate grid. Number one, what are the important parts of the coordinate grid? What's the vocabulary? How does a coordinate grid work? How can you locate a point on a coordinate grid? And then also, how can you plot a point on a coordinate grid? Can you reflect, rotate, or translate a shape on a coordinate grid? And what does reflect, rotate, and translate mean? Might you be asked to find area of a shape on a coordinate grid? The answer is yes. Might you be asked to find perimeter of a shape on a coordinate grid? Again, the answer is yes. And then using Pythagorean theorem, how can you find the distance between any 2 points on a coordinate grid, which is a good way to practice Pythagorean theorem? How you can graph a line on a coordinate grid is going to be something that we're going to cover in slope intercept. So that is its own very large topic. But this is just to get us ready for the coordinate grid. So here we go. Step one, you need to know the vocabulary. So a coordinate grid is made out of 2 intersecting lines that are intersecting at a perpendicular point. So if you look at where this arrow is, that's an intersection point. It's where 2 lines cross each other. You have a line that goes perfectly straight up and down. You have another line that goes perfectly side to side. So the question is, all right, what angle are they intersecting at? And we should be able to say, well, they're intersecting at a perfect 90-degree angle. And the word for that is perpendicular, all right, perpendicular. So you have 2 perpendicular lines. And then most coordinate grids are going to have nice, evenly spaced lines coming off of those lines. All the spaces should be exactly the same width and length apart. And a coordinate grid will end up being 4 different sections. So you have a section here, 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 and here. So the first thing is, what are those sections called? And you might be able to notice they're going to be called quadrants. And Q-U-A-D, quad, means 4. If you're riding on a quad runner, you're riding on a motorized vehicle with 4 wheels. Okay, a quadrilateral shape has 4 sides. So anything with quad is going to indicate 4. So there are 4 quadrants. And here's the way they go. Quadrant 1 is the top right. So the first one, upper right, quadrant 1. Quadrant 2 goes counterclockwise. So it goes 1, 2. Quadrant 3 would be this one down here. And quadrant 4 ends up here. Why is it like that? Who knows? Somebody decided. And then once everybody agrees, that's the way it is. The point where the 2 lines cross is called the origin point. And this one's super important because when you count a point, when you try to find the location of a point somewhere on this 2-dimensional surface, you always start counting at the origin point. The origin point is also known as 0, 0. So if we were to write out the coordinates for the origin point, it is at 0, 0. All right. So it goes 0 left and right, 0 up and down. It's right there in the middle. Okay, origin point. All right. The last things that we're going to cover is what are the lines called? So that's where your x-axis and your y-axis come in. Now, x comes before y in the alphabet, and we draw our horizontal line before we go to a vertical line, because we've been doing number lines for years and years and years. So you're doing number lines or an x-axis line, since you've been in school. And then later, 7th or 8th grade, or maybe even 6th grade, they give you another line, and that's your y-axis. So the x goes first, the y goes next. If you want to get into 3 dimensions, you would have a z-axis that goes through and back into space, and then you're drawing 3-dimensional stuff, which luckily is not on the GED. So to go over again the most important vocabulary: quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. One other thing that I find kind of interesting about that, if you go through the quadrants together, you start at 1 and go to 2, and then go to 2 to 3. Oops, and 3. Oh my goodness. That's the quality you're going to get here. Sorry. And go from quadrant 3 to quadrant 4, it makes a letter C. All right, do you see the C? It makes a C for coordinate grid. I'm sure that's a coincidence, but it is a nice way to remember which way the coordinates go. So 1, 2, 3, 4. Origin point is where they cross. X-axis is the horizontal line. Y-axis is the vertical line. Okay, next, you need to be able to label a point if they give you a point. So they give you a point, and these hearts are going to be the points that we label. And we're going to say, what is their address? What is their location? So all addresses on a coordinate grid are written like this. They tell you what to do on the x-axis first. So they will give you a number. All right, so this one, if you're starting, let's see, I need something that's going to stand out. So you're starting at the origin point. You want to get to this point. You don't just go diagonal, that's cheating. All right, we're going to talk about what do you do on the x-axis first. Well, to get from here to there, you're going to go 1, 2 spaces to the right. So the first number is a 2. You're going to go 2 to the right. And then you're going to go up 2. So 1, 2. So the coordinate point that was labeled this location right here would be 2, 2. That's 2, 2. So right there is point 2, 2. Well, what's the difference between that point and this point over here? Well, this point over here, you got to start at the 0. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. You're going over 9 spaces. So you'd start with a 9. Then you're going to go up 1, 2, 3. So this is located at 9, 3. All right, not too bad. So you always do the x address is given first. So it's always x, y. Just like alphabetical order, x, y, no z's. All right, we're not doing 3 dimensions. What about this one? Well, this one, you're starting here. Let's get rid of some of this. We don't need to get rid of our x. We can leave that there. All right, so we're starting at the origin point. We want to go 1 to the right. So we go 1 to the right. But now we've got to go up 1, 2, 3, 4, 5, 6, 7, 8. So this would be at 1, 8. 1, 8. Now notice all these numbers are positive because they are in quadrant 1. If you're in quadrant 1, both of your numbers are going to be positive numbers. But of course, you could have a negative x, you could have a negative y, you could have a negative x and a negative y, and that's going to change where things end up. So let's start again at the origin point. We're going to clear this all out. And let's try to get to this heart. Well, on the x-axis, if this is 0 right here, if your 0 is right here, that's 0, 0. And you want to go to the left of 0, that is a negative number. So this would be -1, -1. This would be -2. This is -3 on the x-axis. So the first number for this heart would be -3. It would be -3, comma. So you go backwards, 1, 2, 3. But now you're going to go up again, and up is positive. So up 1, 2, 3, 4, 5, 6, 7. My heart's off a little bit. But it's up 7, so it'd be -3, 7. -3, 7. Okay. Leave that up there for a little bit for reference. Now, what about this heart? Again, you're starting at 0 right here. And the first thing you do is move side to side. Okay, move laterally. -1, 2, 3, 4, 5. So it's -5. But then it doesn't go up and it doesn't go down. So the up and down number, you don't want it to do anything. So instead of -5 and a number, you're going to put -5 and then say the directions are go 5 to the left, but don't go up or down, which is 0. So this line on the y-axis is 0. Okay, going up and down, that is on 0. Left and right, it's at -5. So that's -5, 0. Let's go into the third quadrant. We want to get to this heart. We're leaving from right here. You're going to tell somebody, go left. 1, 2, 3. So that is -3 on this line. Then you want them to go down 2. Down 1. Down 2. Down is also a negative number. Okay, so left 3, down 2 would be -3, -2. And if there is a point in quadrant 3, not on the lines, but actually in quadrant 3, it's always going to be a negative followed by a negative. Now, we might have mentioned already that if you're in quadrant 1, it's always a positive and a positive. So they're opposites, which makes perfect sense that they would be opposite, they're diagonal. Over here, though, it's always going to be a negative followed by a positive. So you got to go negative and then up to quadrant 2. So what's this have to be? If that's positive, positive, this is negative, positive, this is negative, negative, what's the only combination we're missing? You can pause the video if you want to see if you're right. But this is what we're missing. We're missing positive first, then negative. So this was negative, positive, it's positive, negative. So if we're looking for this heart right here, and we're starting here again, we would go 1, 2, 3, 4, 5, 6 to the right. 6 to the right. But then we're going to go down 1, 2, 3, 4. So it's 6 to the right, positive direction, but then down 4. And now we're at 6. -4. All right, 6 to the right, down 4. So to the right is positive. To the left is negative. Up is positive. And down is negative. Now, there's a lot of green all over the place. One more heart we haven't checked. We haven't checked this one. If you're going from here and you want to tell somebody how to go, you're going to give them your left and right, and then your up and down, okay? So pause the video, see if you can get this correct. This is a little tricky. Any of the ones on the lines can be tricky. So how far do you go left and right? How far do you go up and down? Okay, pause the video, click back on it, see if you're right. All right, so here's what you should have thought. You should have said, well, I don't want to go left to right. I just want to stay there. So I'm going to have 0 be my first number. And then I want to go down 1, 2, So that point right here is at 0, -2. All right. So given a point on a coordinate grid, can you find its address? That's what we just did. The next thing to do would be, given an address, can you plot the point? So we are now going to take these one at a time, and we're going to take these, we're going to plot them. So the first one, it's a positive number. So I know it's over here somewhere. And we always start counting at 0, 0. Well, this has 2, 7. You're always going to go either right or left with your first number, okay? That's your first number. Then your second number is up or down. So if it's +2, we're going to go to the right, 1, 2, okay? +7 is up 7. So over 2, up 1, 2, 3, 4, 5, 6, 7. And we're right there. And right there's our 2, 7. All right, boom. That's 2, 7. Take a look at the next one. All right, now I'm not sure exactly, well, I'm not gonna lie. I know where this one's gonna go. But think about, pause the video maybe, think about where's -3, +1 going to end up. And for the rest of this, what you should be doing is, when we get to it, pause the video, see if you can figure out where you would put the dot, and then restart the video, see if you're right. I'll leave that up to you and your capable finger pausing button. So -3, 1. -3 is your X. That's your left and right. So starting here, we're going to go -1, 2, 3. But then we have 1. That's a +1. So -1, 2, 3, -1, 2, 3. That's your -3. But then you're going to go up 1, which is going to put us right there. And right there is -3, 1 on that green dot. Okay. Let's take a look at 3, -5. Again, pause. Figure out where it's going to go. I'll stall for a little bit of time here. There we go. Ooh, get rid of that. Okay, 3, 5. So you're starting at the origin point. You're going 3 to the positive side. That's this side over here. So 1, 2, 3. But now you've got -5. You're going down 5. Over 3, but down 1, 2, 3, 4, 5. Almost to the bottom of my screen. All right, so 3, -5. That's quadrant 4. So we have a point in quadrant 1, quadrant 2, quadrant 4. All right. Figure out the next one. -4, -2. All right, 2 negative numbers. -4, -2. You're going to start at 0, 0. -4. 4 to the negative side. All right, 4 to the left. -1, 2, 3, 4. -2, 2 down, like temperatures on a thermometer, right? They go down. So down -1, -2, right there is -4, -2. And that is our third quadrant. So now we have a point in each quadrant. We have 4 more points. Pause the video. I'm going to go through these rather quickly because there's some zeros here, which are a little weird. And then, some practice questions. And we'll see if you can get it right. Okay, first one, 0, -5. So 0 means left and right, we don't move at all. So we stay right here. But then we're going to go down 5. So 0, -5 is going to be 0 left to right, but then down 1, 2, 3, 4, 5. And we are now on the y-axis. We are on the y-axis. This is not in a quadrant. It's on an axis between 2 quadrants. So you could say, well, it looks like it's in quadrant 3, but it also looks like it's in quadrant 4. Just say it's on the y-axis because it's on the y. Okay, 6, 0. So that is 6 to the right, but 0 up and down. So we're just going to start 0, 0 and go 1, 2, 3, 4, 5, 6, and 0 up and down means that it's going to be on the x-axis. Okay, so notice something. If the x-axis number is a 0, it's not on the x-axis, it's on the y. If the y-axis, the second number is a 0, it's not on the y, it's on the x. So maybe that's the opposite of what you would expect, but think about it. And once you do it for a little bit, it'll make some sense, hopefully. 4, -1, starting at 0, 0. 1, 2, 3, 4, right here, but then -1 over 4 down 1 right there. All right, last one on this page. -2, 7. Let me get rid of some dots here. So we're going to go left 2 spaces and up 7. That's positive. That's negative, positive. So -2, 1, 2, but then up 7. 1, 2, 3, 4, 5. Way up there. And you'll notice, you scroll up a little bit, these 2 dots, all right, these 2 right here, they both have the same y-axis because they are intersecting the y. Remember, this is your y, this is your x. They're intersecting the y at exactly the same place. But their x-axis is different. So they're different left and right, but they're exactly the same height. All right, exactly the same height. All right, cool. So we plotted points and we've read some addresses on a graph. Now, this is not a major part. I would not want to study this for very long, but you do need to understand what are they talking about when they're using these words over here. So it's very possible that you will get a question. Hang on. Oh, good grief. I'm allergic to this, apparently. You're going to get a question where they're going to give you 2 shapes. And they're going to ask you, was this shape rotated, translated, dilated, or reflected? So you need to know what the words mean. So that's all we're really going to do here is we're going to go over what the words mean. As long as you know what the words mean, you should have a pretty good chance of getting these correct. So I'm going to pick, I'm not going to do that. I'm going to pick my triangle. I'm going to make a copy just in case I need one. Okay. I have 2 triangles here. They are the same triangle. All right. One is upside down. And I can click on them and I can spin them around and I can do all sorts of fun things with them. So notice they are exactly the same size. So we are going to talk about, first of all, what is a translation? A translation is a shape that is slid to another location. So if you take a shape and you slide it somewhere else, you put it back on the grid. Okay, you can find the coordinate points. You can find the coordinate points. And all of the coordinate points would have the exact same difference. So for example, if this one is at -1, 2, 3, 4, 5, 6, then the same point on the same shape is at 1. That's a difference of 7 to the right. So every one of these x points would be 7 greater on this triangle. Every one of the y points, like this one is up 1, here it's up 1, 2, 3, 4, it's 3 higher. On here, every one of these points is 3 higher than it is on this triangle. So you haven't changed the triangle, you've just slid it somewhere. And you could slide it down, you could slide it over. That's a translation. So anytime you're just sliding the triangle around, you have translated the shape. Okay. Next thing. If I were to, this one's a little trickier. And I'm gonna use purple because purple is a color for tricky. If I were to make a hinge out of this corner, and I were to take this and take it 90 degrees to the right, 90 degrees to the right, what would it look like? Well, the trick is you got to use your hinge point. So now my computers won't quite do that because notice how that point's moving. That point wouldn't actually move if it was hinged down. That would be a 90-degree rotation. So rotate, when you rotate something, you move it in a circular motion. So that is a 90-degree rotation. Clockwise, because the shape that a clock goes. If you took it the other way, it could be 90-degree rotation to the left. So rotation means you're moving some kind of thing, you're taking it and you're rotating it. Okay. Dilation. A dilation is when you're actually changing the size of it. So if I took my numbers here and say I doubled them all, or somehow increased all of my numbers to make the same shape but bigger, that means I dilated. All right. We won't go into where you hear the word dilate the most, but I guess your eyes, if you get your eyes checked, your pupils can dilate, which means they get bigger or smaller. All right. Remember, this is for my class people. They understand my humor. The final one is reflecting a shape. So if I wanted to reflect a shape, I would pick a line and then I would flip it over that line. So for example, if I wanted to reflect this shape over the x-axis, it's like taking this and flipping it down. So it would look like this. Oh, not quite. It would look like this. Oh, I gotta get some more room. There we go. So it would look like this. Okay, that would be that shape reflected over like a mirror over the y-axis. Now with the triangle, you could have also said, well, how do we know that that wasn't rotated 180 degrees? Well, with a triangle, you'd have to pick kind of a corner to rotate it on. And again, not a major topic, but this is what the words mean, okay? So reflection, flipped over like a mirror, dilation is resized, rotation is spun one direction or the other, and translate is a slide. All right, moving on. We've got some questions here we are going to skip. It is possible that they could give you a shape on a coordinate grid and ask you to find area and perimeter. And we could call it centimeters or we could call it units, it doesn't matter. And you'll have your geometry formulas. So let's just make a shape and say, okay, well, how would we do it? Well, let's go here, we'll go down to there, we'll just do a rectangle. Rectangles are pretty easy, right? All right, so that's supposed to be a rectangle. What's the area, what's the perimeter? Well, there's a lot of ways you can do it. You can just count each block. You can do that. You could also write out the coordinate points. So this is 1, 2. So that's at 1, 2. This is at 1, -1. This one's at -1, 2, 3, 4, 5, 6, 7, 8. So -8, 2, and -8, -1. Then you've got to find the length and the width. So what's the difference between -8 in the x and 1 in the x? Well, on a number line, if you have a 1 and a -8, the value of the difference between those two things is 9. So this side is 9 blocks long. This side's a little easier to see. You can see it's 3, but also on a number line, the difference from -1 to 0 to 1 to 2 is 3. Now they're going to ask you a question like this because they want to know how well do you understand number lines and being able to find the difference between those integers. This is a great way to test people on negatives and positives and counting the difference between them. So area, if it's a 9x3 rectangle, your area is equal to your length times your width. So your area would be equal to 9 times 3. So your area would be equal to 27. I'm just going to put units squared. All right, because your area is this whole shape inside here. And you could also count all the blocks. That would be a lot of work, and you might count wrong. All right, so 9 times 3. If they're asking you for a perimeter, then you're looking for the distance around it. And what I tell my students is just count it up. You don't need a formula. 9 plus 3 plus 9 plus 3, or 9 plus 3 times 2 because you have it twice. So 9 plus 3 is 12, plus 9 plus 3 is 24. So your perimeter is 24 units. So that's how you would do a basic rectangle. You might have a different shape. You could certainly have a different shape. You could have a triangle. You could have a rhombus. It could be anything. But just remember, as far as height goes, or let's just do real quickly, we'll throw a rhombus on here just for fun. So because nothing says fun like a rhombus. All right. Nothing says fun like a rhombus. It is very true. Okay, so what measurements do you need for a rhombus? Well, you need to know both the bases. So this base is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's a base of 9. This base is only 1, 2, 3. Then you also need the height. So you're looking for a line from the top. Do a dotted line here. You're looking for a line from the top to the bottom. And you want that measurement. That's your height, which is also 3. So there's lots of formulas that you could use. But the official formula for a rhombus is area equals 1/2 times the height times base 1 plus base 2. So that means you're going to do area equals 1/2 times 3 times 3 plus 9, or 9 plus 3, either way. So area equals 1/2 times 3 times 12. Now you can go ahead and do the whole thing. 1/2 times 3 times 12. I would do half times the 12 first. I'd use the associative property. Half of 12 is 6. 6 times 3 is 18 blocks squared, or units squared, whatever you want to call it, centimeters squared, I don't care. All right, it's something squared because it's area. Now, they will not ask you for perimeter, because to do perimeter, you'd have to cut these into triangles, you'd have to use Pythagorean theorem, which is what we're going to do next. All right, so we're really getting there. We've done a lot. One more thing. Finding the distance between any 2 points on a grid. To do this, you have to use the formula for Pythagorean theorem, which is how you find the long side of a 90-degree right triangle. So let's make a triangle. So here, let's make 2 points. Okay, we're going to use the triangle, but they're just going to give you 2 points. So let's say they give you this point and they give you this point down here. So you got a point at 3, 1, and you've got a point at negative 1, 2, 3, 4, 1, 2, 3, 4, 5, negative 4, 5. Well, if you were to draw that line, now I really don't want a dotted line. I really want a straight line. If you were to draw that line, you'd say, well, it's longer than the difference between the x's, which is 4 and 3, negative 4 and 3. Well, the difference would be 7, right? So we know it's longer than 7, because 7 would be from here to there. We also know it's longer than it is tall, which is from here to there, which is 1, 2, 3, 4. So we know it's longer than 7. We know it's longer than 4. So it's longer than the difference between the y's and the difference between the x's. But we don't know the exact length. And this might not come out well. I've got a calculator here just in case, because I didn't plan on making this perfect. So this is 7. And this is 4. Well, the Pythagorean theorem says, if you take the two sides that are the shorter sides and square them and add them together, they will equal the square root of the third side squared. So it looks like this: a squared plus b squared equals c squared. Now, again, we're just looking for c, but to find c, you need to triangulate it and use the a and the b. So it doesn't matter which one you call a or which one you call b. So I'm just going to put 4 squared plus 7 squared equals c squared. All I did was put the 4 in for a and 7 in for b. Now I'm going to do 4 times 4. So I've got 16 plus 7, not 7 times 2, 7 squared, which is 49. 7 times 7 equals c squared. I'm going to add 16 and 49. Well, 16 and 49, 6 is a 5, 1 plus 4, okay, the 1, I think it's about 65. 65 equals c squared. So is that 65? No, it's going to be the square root of 65. So to get rid of a c squared in algebra, you have to take the square root. That's the opposite. So I would do square root of c squared, which cancels, and I need the square root of 65. It's a calculator problem. However, we know that 64 is a perfect square because 8 times 8 equals 64. So this is going to be a little bit more than 8. It's going to be 8.1, maybe, something like that. So you grab your handy dandy calculator, you clear it out, you type in second, I think it's second x squared. Yep, that'll work. 65. Enter. Oh, didn't give me anything. You hit the toggle button. And here we go. The official answer is 8.06. And then it's got some 2s and a 5 and some 7s and a 4 and an 8. We don't care. 8.06. Basically, it's 8.1. It's a little more than 8, which is about what we thought. So to wrap this up, I'm going to give you one more here. I'm going to clear all this out. Oh, no. There we go. So I'm going to give you one more. I want you to find the distance between the two dots. All right. So find the distance between the two dots. If you can do that, not only are you getting good at Pythagorean theorem, but you're getting good at your coordinate grids. So I'm going to put a point here. I'm going to put a point right here. What is the distance between those two dots? I will show you the answer in a minute, but hit pause, look at it, see if you can figure it out on your own. All right. All right, so hopefully that went well. The first thing I would do is I would draw my triangle that I want to use. I would draw it like this. I would label the measurement of the sides. We really don't need the points, except if you cannot count the side measurements. So if this is on a blank piece of paper, which it could be, then this point is at -2, 1. This point would be at 1, 2, 3, 4, comma, +1. And this would be at 4, comma, 1, 2, 3, 4, 5, 6. So let's say all they gave you was this. How would you know the sides? Well, this side is the difference between the 6 and the 1. So this has to be 1, 2, 3. Oh, I counted wrong. Hang on. Oh, I made a mistake. Okay. So it's not at 4, 6. That just goes to show you gotta be careful. So 1, 2, 3, 4, 5, 6, 7. But of course I caught myself because I was checking. So if it's at 4, 7, 7 minus 1, this side is 6. Now you got the difference between -2 and +4. Oh, which is also 6. How about that? I drew an isosceles triangle, a right isosceles triangle even. All right, so A is 6, B is 6, and we're looking for C. We don't know, but here's where we do our work. So A squared plus B squared equals C squared. 6 squared plus 6 squared equals C squared. 6, not times 2, but 2 6's multiplied together is 36, plus 36 equals C squared. 36 plus 36 is 72 equals C squared. And to get rid of the squared, you have to do the square root. So we're going to do the square root on both sides. Whatever you do on one side, you got to do on the other. These two cancel out and you just get C equals square root of 72. 8 times 8 is 64. 9 times 9 is 81. So this is going to be closer to 8.5. It's somewhere between 8 and 9. So again, calculator. Second button, the X squared button. Put your 72 underneath the square root symbol. Hit enter. Oh my God, it says 6 root 2. 6 root 2? 6 square root 2, that is not helpful to me. I want an estimated number. So I'm going to hit my toggle button. Then it gives me my decimal version, which is 8.48 whole bunch of stuff. We're going to call that 8.5. So we'd be looking for an answer of somewhere around 8.5. And does that make sense? Sure. If you look at it, obviously the longest side is longer than the other two sides, but not by a ridiculous amount. You know, if you got like 24, that wouldn't make any sense. But 6, 6, 8.5, sure. That makes perfect sense. All right. Anyway, that is it for the quick rundown on the coordinate grid and some problem types that you might have on there. This has been Math Miker. To all my students and everybody preparing for the HISET of the GED, good luck, persistence, resilience, keep trying, keep practicing. You will get there. I've seen lots and lots of people do it. You can do it too. And when you do, leave a comment and hopefully I helped a little bit. All right. Have a great day. Thank you.